Okay, so in this video, we are going to be taking a look at ways that we can add and subtract mixed numbers. So if you could take out your notes and make sure you are following along, make sure you date it. With today's date. As always, if you have questions when you're done, make sure you come see me. All right, so we're going to start with adding. But just as a general note, for both adding and subtracting, the thing that I want you to remember is just like with fractions, we're going to need common denominators. So we're going to start by looking at what happens when we add mixed numbers. So for example, if we have 3 3/4 and I am adding 1 3/8. So just as a review, visually, what would happen is I could represent 3 3/4 with 3 full circles. Oops. And then we would have a 4th circle split into 4 parts, where 3 of the 4 parts were shaded. And then our second 1 3/8 would be an additional circle. Oops. That's completely full. And now this time, because it's 3/8, I'm actually going to go and think about adding it to my picture up here. But eighths, oops, I'm going to look at splitting this. So my 1/8 would be here, 2/8, and then I would need one more circle split into eighths with one more piece shaded, and then I can count what I have all together. So here I would have 1, 2, 3, 4 complete circles that we had originally, plus the one that we created after we took the 3/4 and added 2/8, plus 1/8 of an additional circle, for an answer of 5 1/8. Hopefully at this point we are feeling that we don't necessarily need to visually show our thinking all the time. So the other way we can think about this is finding a common denominator. In this case, our 3/4 are going to become eighths, so I'm going to multiply each by 2. This becomes 3 6/8, 1 3/8. I'm going to add 3 plus 1 is equal to 4, which in our visual model was represented by our original 4 completed circles. And then we have 6/8 plus 3/8, which would be 9/8. But since that is a fraction that is greater than 1, we need to regroup. 9/8 becomes 1 1/8, which we saw in our visual right here with our 1 1/8. So I add that to the 4, and our final answer is 5 1/8. So that's probably the most efficient way to add mixed numbers. So now let's focus on subtracting. Subtracting is typically where students have more trouble. So we're going to talk about a few different ways that you can subtract mixed numbers, starting with what I think visually works out the best to what students typically in the past have had the most trouble with, but is probably the one that is most commonly taught. So we're going to look at subtracting the values of 5 1/3 minus 2 7/8. Now I'm purposely picking one where our second fraction is larger than the value of the first because that's where students typically have trouble. Our first strategy that we're going to use is actually we're going to add or count up. Some of you may have seen this strategy when you first learned subtraction. It might be new for some of you. When we add or count up, we're actually going to start with 2 7/8. And I'm going to think about what do I need to add to that fraction to make a whole. In this case, it's missing one piece. So I'm going to add 1/8. And by doing that, it gives me a value of 3. On my next line, I'm going to start with 3, and I'm going to think about how many whole circles or squares or whatever I'm visualizing what I have to add to get to my other whole numbers. So in this case, 5. So here, I have to add 2, and that's going to give me a value of 5. Then I'm going to start with 5, and I'm going to think about what do I have to add then to get this second fraction. In this case, I'm going to add 1/3, and now I'm at a value of 5 1/3. So I started with my 2 7/8, and I ended with my 5 1/3, and now I'm going to add these values in the middle. So I have 1/8 plus 1/3 plus 2. Now, just like before, when we were adding fractions or mixed numbers, we need to find a common denominator. So for 8 and 3, it would be 24. So I'm going to multiply and make this into 3 24ths plus 8 24ths plus our 2 wholes still, which we don't have to change. 8 plus 3 gives us 11 24ths plus 2. So our difference is then 2 and 11 24ths. And this would be our final answer. So that's the first strategy. Our second strategy that is commonly used, or more commonly used, I should say, and probably what students typically have an easier time with understanding, is using improper fractions. This strategy translates really well when you get into higher math and are working with positive and negative values. The downside to it is sometimes your fractions get quite large, and I'll show you what I mean. So we're going to use that same set of numbers. We're going to use 5 1/3 and 2 7/8. So when we think about doing this, the first thing I'm going to do is I'm going to change them both into improper fractions. So I'm going to do 5 groups of 3, which would be 15, plus 1 gives me 16/3, and then 2 groups of 8 is 16, plus 7 gives me 23/8. Now I have to go through the process of finding a common denominator. Still going to be 24, so I'm going to multiply each of these by 8. And each of these by 3. And this is where it gets a little bit more complicated because sometimes it's out of what our normal multiplication facts would be. 16 times 8 actually gives us 128 24ths. And then 23 times 3 would give us 69 24ths. And now I'm just going to subtract. So I have my 128 minus 69 You can do all the sorts of regrouping and things like that if you would like. So we end up with 59 24ths. And we look at 24 can go into 59 2 times with 11 left over. So same answer, but just a different way to approach the problem. The last way that we are going to look at is actually using regrouping. So our third strategy with regrouping is the one, that students tend to struggle with, but is often also the one that's typically taught that your parents might be most familiar with. Going back to that same set of numbers, so we have 5 1/3 minus 2 7/8. What I'm going to do is, instead of horizontal, I'm going to set it up as a vertical problem. So I have 5 1/3 minus 2 7/8. I'm going to go through the process of creating a common denominator. So times 8 times 3. So now I have 8 24ths, but I need to take away 21 24ths. So if you think visually, if I only have 8 24ths and I need to take away 21 24ths, I basically need to cut up one of my other wholes. So I'm going to take one of those 5 complete circles and leave me with 4. And now I'm going to take that circle and think about cutting it into pieces. Well, in this case, remember, our denominator is 24. So that's what we need to add, because every time we take a whole, it's going to be cut into 24 pieces. So I'm going to do 8 plus 24, which gives us a value of 32. And now that's our new numerator, because I have my 8 from originally and then 24 for my newly sliced circle. And now I can subtract. So I have 32. I take away 21. That leaves me with 11 24ths. And then I have 4 complete circles. I take away 2 of them, and that leaves me with 2 as well. So once again, we get that answer of 2 and 11 24ths.